Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our deep programming language series. In today's lesson, we're going to be talking about enums in the deep programming language. So I've previously been talking about things like const and immutable in this series, so make sure you check out those videos if you haven't already. But enum is really some other type of immutable type that can't be changed. It's a constant value. Now, when and where this constant value is created is something that we'll have to talk about. So let's go ahead and dive into the language reference and understand enums in the deep programming language. So I'm going to go ahead and just take us to the documentation here, take us to the language reference, and if we scroll down a little bit here, we will see enums. Oops, there we are. And basically what an enum is a way to create and group a number of constants together. So you've probably had, or maybe you've seen some code at some point where you need to declare a bunch of variables, various constants, things like days of the week, for example, is a constant one, or one that we're going to look at is different error codes. And rather than creating separate named variables for those, or even constant variables, we can group them together in an enumeration to show that they're related in some sort of way. So it's a nice way to group things, and we'll also see how it can make your code a little bit better. So that's the idea with enums. Now, the deep programming language offers a few different things that you might not have seen in other programming languages, say if you're coming from a C programming background. So let's go ahead and keep this open for a few moments and then look at some of the different features of enums. So let's just go ahead and start by creating a simple enumeration here. I'm going to go ahead and move that over here just to show you again what can be done here. And again, the scope at which I create the enum matters. So whether I do it in my main function or make it globally available for this demo, I'm just going to go ahead and do it in my main here. And let's just go ahead and mirror this example that we have here from the documentation, X. And I'll actually, let's do one that you'll commonly see. Let's do days of the week. And then you'll have something like Monday, Tuesday, Wednesday, Thursday, Friday. Okay. So something like that. And you'll notice immediately, let me go ahead and put a semicolon there and run it. We don't need the semicolon after here. Okay, so that just in case you get that little error message, and we could get away with this here. Because we know what the syntax is, it's not ambiguous in any way. So that's the named enum here. Now, what are the actual values stored inside of Monday, Tuesday, Wednesday, Thursday, Friday, and so on? But the real point of this is not necessarily to be sort of reading into the values here, but we can, and again, it depends what you want to do, or what meaning you want to give these. So for instance, let's just go ahead and write out from our enumeration, days of the week, Monday, and let's go ahead and see what value we get here. So if I go ahead and run this, you'll see that, well, it is in fact giving us Monday here, okay? And let's go ahead and see, is this a string here if we do a comparison? So I'll do a comparison here. And well, we're getting incompatible types here. Okay, so mon here, which is part of days of the week, is not the same as the type of string here. Okay, now the default value here for our enumerations is an integer, just like in other programming languages. So let's go ahead and see that by doing a formatted string here. I'm going to use the format specifier here. And then if I go ahead and run this out, you'll see that it's 0 here. Okay, so if you want to give some sort of meaning to your enumeration, just like in other programming languages, you can assign that value. By default, it's 0, or I can make it 6 here, for instance. And if I run it, we'll see it's 6. And then let's just go ahead and see that Tuesday should be incremented by 1 here. Okay, so let's go ahead and run that here. And you'll see that we get 7, Wednesday would be 8, Thursday 9, and Friday 10, and so on and so on. So D, just like other programming languages, will allow you to just, increment as long as you specify one of these types here. Now, of course, if you do want, you can change the base type here. So it could use something like a string here. And let's go ahead and run this, and then we'll see that, well, now we are getting an error for this conversion here. So let's go ahead and see what's going on here. Or what rather I need to do here is actually specify Monday equals, Monday, and so on. Now, if I use a type like a string for my enumeration, and I've got to give myself a little bit of a space here, you're going to see that, the compiler, while it's pretty smart and it's going to give us a helpful error message here, it's basically trying to figure out Monday +1 for Tuesday, and then again, increment, and so on. So if we use something like string here, and that's why it's giving us this incompatible types for Monday +1 here, we do have to specify for all of these some sort of string here. So let's just go ahead and fill this in very quickly here. Tuesday, Wednesday, Thursday, and of course, Friday. Okay. And now I can actually run this. And let me correct one more error here with our format string here. We want %s for string here. And now we can actually run this and we'll get our associated Monday and Tuesday. All right, now we're probably wondering why I printed out Monday instead of, or rather MON instead of the full Monday here. And I should capitalize these days of the week. But the idea again here is what we actually can do here is if I do days of the week dot Monday equals, if I want to actually just check what this constant is, then I can actually through this comparison see that, the actual string that is stored in this enumeration is Monday. If for some reason you need to, use this constant here. But the formatted string here is just giving me the sort of name of the enumeration here, okay, which is just MON here. Okay, so maybe that's a little bit more descriptive. Maybe it's a little bit of a surprise, but that's the functionality. Now, let's go ahead and look at a few things with enums here that I think will also be useful here. Let's go ahead and see down in the D programming language here, just some of the properties here that we've seen. Dot init, min, and max. I'll go ahead and leave these at the top here, and we'll just see by example what we have here. Let's just go ahead and write some of these out here. So if I do days of the week, the init, let's go ahead and see what's the first thing in our enumeration. Well, it's Monday. Okay, that's the first thing that's listed here. So it's the first value, and that's important to find here. Now, of course, if you have something like this example here on the right side where you have numbers and we do something like min, it will find the minimum value here. Now for us, let's go ahead and see what the min is here. And let's go ahead and add it to our list, or our output here. Oops, there we are. RDMD main. And it says error min day of the week has no min property because the base type is string, is not an integral type. Okay, so it looks like we lost that sort of power here with our enumeration. So again, it doesn't really make sense here. Now let's go ahead and see size of here. And again, it has to be an integral type, right? We don't know how to, maybe there's some way to add in or maybe override some functionality here, or you would write your own function to sort of compare all of the, and we're going to get to this, basically enumerate through all of the enums here and return you the init if you needed, or rather the min or the max if that was needed. But if you need that functionality with an enum, you probably just want to use min and max. So anyways, we can at least see the size of here. And the size of, just to be 100% clear here, is the size of the base type here. That's why it's giving 16. So a string, as we've learned, is usually on a 64-bit architecture going to be 8 bytes for the pointer to the data, and then 8 bytes for storing the length of that string. Okay, so just a few different things to keep in mind here. Okay, so that's just our little days of the week example here. Let me go ahead and just comment this out here as we move forward, talking about some other features of enums. We don't have to name them, so we have anonymous enums here, and they're by default integer if you want to use them. But let me get to this idea that might be a little bit new, and then we'll get into some more examples here of what's a manifest constant here. Okay, so if you just have one value here, so let's say I just have something like state or something, I can just give it a value here. Or let me actually give a more pragmatic version. Something that you might do in your software is like the version number here. Now, version's a keyword in D, so I'm going to put an underscore after it. But, you have version 9 of your software. And let's actually write out, just so you can see that value here in version. Okay. And here it is, 9 here. So you might have something like that. And as stated, you can omit the brackets here if you just have one value. And this is something that D calls a manifest constant here. Again, don't need to specify the type, just like with const and stuff, it can be inferred. But again, you might want to be explicit. For example, if this is a float, if you're representing your version of your software with a float for some reason, which I probably wouldn't recommend. So let's change that back to an integer. That might be something you can do here. So the trick with these are, as you'll read through, is that they're not L values. So that means, I can't take the address of this. And again, sort of the advantage of that, since it has no address, it only exists in the memory of the compiler. So that means, it is going to do a sort of replacement or compile time computation, which is in general a good thing, right? That's saving us computation, okay? So that's the idea there. Now let's just go ahead and look at, with that idea, so that's manifest constants. I'm going to go ahead and comment this out as well. And let's just do an example again where you might use enums, because I often have folks wondering about, where would I actually use enums for a sort of pragmatic example. You might have something like error codes or something. Rather than defining a bunch of consts with the different codes here, you could do something like this. I'm going to just explicitly say that they are unsigned longs or ulongs in D. And let's just go ahead and say, you have something like a seg fault, crash, warning, some different values here that you would have, okay? And something that you might want to do in your actual program, first and foremost, is just iterate through the different error states that you have. So let's just go ahead and do for each of our error codes. And let's actually use this type. Because again, the point of having an enum is to avoid having to, say if, let's say we had something like a string where I was storing the error codes, okay? And because we might want this to be mutable, we might call it a char string here. And you want to say it's like okay or something, so it hasn't crashed. So we want to avoid writing code saying like if error codes equals okay, do something else, else if, error codes equals whatever. All these sort of if statements here, right? This is an advantage of a enum. So if we're just able to create a function that takes this in, so let's actually use error codes. And again, it's a name type. So I'm going to say, program state or something of this nature. And then I'll just go ahead and enumerate through each of the different program states here just to show you what we have here. So for each, let's just call this element in our program state. Let's just go ahead and write it out just so we can see what each of the elements are. Let's see if this will even work here, first and foremost. Okay, first and foremost, we get a error here. It's saying program state of type error codes. Okay, so that's okay. And this is just something in D that we have to do. We have to introspect, and we haven't talked about the type traits library too much, but we have traits here. And we need to look through the enum members, and that's templated here. Okay, so that we can actually write them out here. Oops, and let me go ahead and help you just parse this out here. Program state, I mean, this is a type of our error code. So if I want to actually introspect and look at error codes, so something that we would know at compile time, right, we have here, I need to actually use the declaration there, right? And so here we can see the different types of crashes that we could have here, okay? So let's go ahead and, right, we have all of our enumerations here. And let's go ahead and set our program state equal to, when we initialize it, an error code of, seg here, okay? And then I'm just going to write here and check here if program state equals element, write out what that code is, okay? Let's just go ahead and write out program state. Okay, so let's go ahead and see if we found something. And in fact, through our enumeration here, our type here, I'm able to look through all the different possibilities and just see if our program state, which one it matches. And I could print it out and get some information there and so on. Okay, so that's just, again, showing you how to enumerate through this. I wanted to show you with the for each here. Now, again, how you pragmatically might use some of this. So let's go ahead and just comment out this example for now. Is to do something like a switch statement. You might do a switch on the program state, and then you would do something like come in here and say the case here that you want to handle is seg, and then we put a breakpoint here, and then you might have another case here for a crash that you handle, and put a breakpoint here, and do a case for warning. Okay, and then have another breakpoint here. Okay, so something of that nature here. Now a few different errors here. And this is just me mixing some things up here. So let's go ahead and put the colon at the right place here. And let's go ahead and put some of these here. Again. And I'm expecting at least one more warning here. Undefined identifier seg, and so on. Okay, so it's trying to figure out where are these cases coming from. Now you can see I'm doing this through the different enumeration. So again, let's group them together here. And I'm going to go up here to error codes dot seg, error codes dot crash, and error codes dot warning. So again, you know, it can be a little bit versus having these as free constants. Again, I'm just trying to show you the advantage of sort of grouping things logically together, right? To say that this is a segmentation fault or a crash or a warning or whatever, they're all part of error codes, versus if you were to instead say const ulong seg equals, you know, some value like this. Ulong crash equals, you know, 1, const ulong warning equals, and then maybe I make a mistake and do 3 and skip a value or whatever. Again, I don't have to worry about that with the enums here, okay? So what I'll go ahead and just add a comment here and say enum is better because we're logically grouping a set of related things together, okay? That we might want to enumerate through and find the separate cases, okay? So I fixed that here, and again, just showing you how to do this switch case here. Now let me go ahead and save this and run it. Let's keep progressing forward here. And then you'll notice it says, okay, without a default here, because again, the decompiler is smart enough to say, well, we need a default case here. And then usually in this instance, it's giving us a few different options here, or I could have a final switch, or I'm going to put in the default here. And then what I'm going to do is just put a assert 0 here. So basically that means is later on in my code, I mean, this compiles now, if I decide, hey, there's, you know, some other condition here, you know, everything is fine, you know, our state here, and then I ever get in a program state where I am in my enumeration saying, hey, everything is fine, then it's going to crash here and essentially force me to implement that. So that's what I'm looking for. And that's the kind of thing that you might miss with, for instance, if I have a bunch of if conditionals. So again, just showing you an example of where you could use this tool and where I think it would be useful. All right, so with that said, again, I just want to go ahead and show you this tool here that we've learned about Enum, how to create them, a related set of things together. If I do something like, you know, program state plus plus, just a reminder for what we've been talking about, you know, I can do this as long as, you know, I have this integral type here. But let's go ahead and try something like plus equals 10 here. And then it looks like we will get an assertion failure because we're not handling that 10th case. So again, enums are a little bit safer in that sense once we create something with a type and we can check these conditions. So that's going to go ahead and show us that value. Again, enums are related to this idea of immutability, meaning I can't change this value of seg to 27 while the actual program's running. Let me actually show you that. If I try to say errorcodes.seg equals, you know, 57 now, you know, that's not allowed, right? You can't modify this manifest constant, this thing at compile time that is created, okay? The last thing I'll show, since I haven't shown it yet here, is that, again, and let's go ahead and just take a piece of code that we have here. Let's go ahead and just make this a little bit larger so you can see. And what I want to do here is let's just go ahead and take this switch statement here in our code. I'm going to go ahead and yank it out here, and I'm just going to paste it into a function. Again, just showing you how to, you know, write this sort of function here, check state. It's going to take in something that's an error code. and I'll call that the program state again here. And we'll actually call this function. Now I need to make sure that my error codes are at the right scope here. So let me go ahead and move those up here. And let's just go ahead and with error codes here, just refactor this program a little bit just so you can see everything on the same screen. There we are. So now I'll just go ahead and call check state, pass in this local variable program state into here. It'll take it in here and check all the conditions here. And let's finally, just to review here, let's just go ahead and do a write line here of program state here. Okay, we'll just do that at each of the conditions just so you can see where we land. And let's just go ahead and do an rdmd. And you can see we are in the segfault state, which means we need to fix something here. Okay, so that's an idea, sort of a pragmatic example. Again, an enum is a named type. We're grouping together related things that are constants that can't change as a way to sort of organize our program. And they're useful, or at least I found them useful in things like switch statements to make sure I'm handling all sorts of the conditions versus lots of nested if statements. All right, folks, so with that said, I hope you enjoyed that lesson on the D programming language. I hope you found it insightful. As always, if you want to find these programming language lessons in one place here, I have on my website, courses.msha.io, the D language series, so you can sign up and track your progress if you find that a useful way to learn. But otherwise, as always, feel free to comment below if you have questions about enums, if you use them for different things, or have explored some of the other D language features with them. Feel free to share that below. And thank you again for your time and attention. I'll look forward to seeing you folks in the next video.